Hi, everybody. My name's Robert Douglas, and I'm here today as a last-minute replacement for whoever was supposed to have this session slot to talk to you about spec-driven development with Spec Kitty. Spec Kitty is an MIT-licensed Python command line tool, and I'm going to tell you what it does, but to, cut to the chase, it sits in between an agentic hardness and you and your model, and it guides agentic coding processes in spec-driven development. But we're going to back up a little bit, and today's going to be a presentation in 3 acts. We're going to talk about how coding agents actually work. So we're going to talk a lot about the harness and things like skills and tool calls. We're also going to look at a recent security incident, which was mind-bending in its vastness and dangerousness. And then we're going to look at spec-driven development with Spec Kitty with the context of those 2 things in mind. So I've been coding with agents for at least 3.5 years. Can I see a show of hands? Who codes with agents regularly now? Yes. Great. Most of you. Can I ask who uses some form of spec-driven development already in a framework? Fantastic. Okay, great. So some of you are new to the topic, and there are several frameworks out there that do a similar thing to Spec Kitty in their own way, so you can research which one is the flavor that you prefer. Kind of like Linux distros, only not as complicated. So people are seeing real gains from agentic coding. Way back in 2025, even 52% of developers were reporting positive productivity gains, but the level of distrust is very high because people, 1, don't really believe that the code is going to turn out good, and 2, they don't believe that it's safe to do it the way that they're doing it, and 3, digital sovereignty is a big topic here today. They don't believe that the people serving them the models are going to take care of them in the long run. So there's some other statistics here. I'll send the slides out later. But the models are not the bottleneck. It's coordination. It's the topic of turning human intent into context for models and execution, and making sure that you don't get stuck reviewing thousands and thousands and thousands and thousands and thousands of lines of AI slop, and that's your new job. Aren't you glad you're a developer? So why did I build Spec Kitty? Well, it turns out I was building a product with agentic coding, and I was unhappy with the quality, and it wasn't going quite fast enough, so I decided I would build something that would help me do that. So Spec Kit from GitHub had just been released about a little bit over a year ago. And I thought, okay, philosophically, there's a lot there that I like. I didn't really like the tool, and there were a couple philosophical points where I differed in my approach just as an individual developer. So I did what you do in open source, and I forked Spec Kit. And because I was a little bit cheeky in that moment, I named it Spec Kitty. Thank you, TY, get it? And the logo was also nice because specs are spectacles, so it's a kitty with spectacles. All right, let's talk about how these things really work. It's interesting. What's a harness? So a harness, so language models like GPT, Claude, or Llama, or gosh, what are the names? There are hundreds of models these days. They turn text into text. They can also turn images into text, or text into images, or sound into sound, or whatever. But the ones that we use for coding, they principally turn text into text. It just happens to be that the text is code. So you give a prompt, build me Facebook. The harness takes that and assembles the context. It's got a systems prompt that's the main guiding instructions for the model. It's got tool schemas, so the model can know in its context what tools it's able to call on your computer. And it sends to the model that, and usually over just a normal HTTP request, API, whatever, and it comes back, whether it's your local machine or somewhere in the cloud. Doesn't really matter. The abstraction layer is that there's an API with which you speak to the model. Request, response. We are all familiar with that. So you get the response from the model, and the harness then goes to work. The model has reasoned about what you've asked. It's reasoned about its system prompt. It's reasoned about the list of tools that it sees available, and it thinks, okay, given the tools that I have available, what do I need to know to take the next step? It might be that it needs to ls the directory that you're in to see the files that they're there. It might be that it needs to cat the first 20 lines of every file so it can read the headers and see which file it needs to explore more. And then it might progressively read the file that it thinks it's interested in 100 or 200 lines of code at a time, collecting everything that the model thinks it needs to solve your problem progressively over many requests and responses. And then it finally says, dear harness, write 15 lines of code at line 20 in file X. And the harness goes and uses a tool to inject new code into a file on your file system, and that's how it works. The model never touches your system. It asks, it begs, it pleads to touch your system. And this is where things get very interesting, because the models have wills of their own. You've given it a goal. It will do everything in its power to achieve that goal. So we've got lots of psychology in human history and lots of agentic examples of what happens when you give something a goal that it can't immediately achieve. It tries to go around the barrier, whatever the barrier might be. If the harness is the barrier and the harness is not secure, the model will go around it. So what the harness manages is the context that's being sent to the model, the capabilities of the model, or of the harness. So there's a tool registry, read, edit, bash, search. There's also model context protocol servers, MCP servers, which expose other tool sets that might be local or remote. Subagents, where the harness can spawn another agent, which is another set of request response cycles that report back to the main agent. Hooks that the model never sees, so the harness might say, before anything happens, I'm going to fire this hook in case a system wants to interact with me as the harness before the model gets any information. Boom, hook fired, model never sees it. Interesting. And it goes on and on. So then the workflow comes in through things like slash commands that you as a user can invoke, skills that you can invoke explicitly or the model can choose to invoke implicitly, and we'll see all of that inside of Spec Kitty. Question? May I give you the microphone for this so that it gets recorded? Is it on? Video Angel, what do we need to do for microphone? She's got it.
Sorry for my bad English. Harness means tableware, dishes, crockery, kitchenware. So what?
That's not really the right definition. A harness. What's the word auf Deutsch for what you put on a horse to direct it? Okay, that is what we're talking about. All right, so now that you understand its purpose, it's also your first line of defense, okay? What good harnesses enforce are permissions, prompts with allow lists per tool, sandboxed execution, controlled file system and network access, approval modes, so you can do graduated safety things like read anything you want on my file system, but before you touch my system settings, kill yourself. So what the model cannot guarantee, what the model can't guarantee is that the harness won't do something bad. And you can also not ask the model to not do bad things. You can't say, there's several things you can't ask of a model. You can't say, don't make mistakes. You can't say, don't use M dashes, because as soon as you say M dash is in the context, and it's going to say, ooh, M dash, I'm going to use those. You also can't say, don't delete my file system. Okay? It has no concept of your physical reality and your other goals other than what you've stated to it. And if it thinks that an RM minus RF is the answer towards solving the goal, it's just going to do it. It's going to ask the harness to do it. So what does that mean? You want a harness that will say no. So there are some vendor harnesses. There's Claude Code, Codex from OpenAI. So Claude Code is from Anthropic. Who has used those? All right, those are the gorillas in the room. They have defined basically the category. Claude Code was almost a mistake from an engineer inside of Anthropic who just built this thing, and some people thought it cool, and they released it, and then boom, it blew up. It blew up big time, and now it's probably one of their biggest adoption drivers, and it's changed our industry massively and permanently. Codex is the very good answer to that, which is actually an open source harness. So Anthropic's Claude Code is not, unless they leak it. And Codex it's hard coded to talk to ChatGPT, but you can fork it. I'm going to show you Open Code today. Open Code's really cool. I get a 2 thumbs up from the back. It's got a great architecture. It is maybe not the most efficient harness overall, and I have a friend who I respect a lot that says that it's vibe-coded slop, but I like it, I use it. So I'm going to show you Open Code today. It's got a client-server architecture so that there's always a server that's running, and whether you're working in your shell or a desktop app or in your IDE, then it's always just talking to this back-end server, so it's a very consistent and scalable approach, and you can put the server in your own cloud and then coordinate many, many things all at once. It's got a language server, LSP, built in, so 30 languages will be looked at they get looked at in their structure, and the structure gets shown to the model, so it doesn't have to just grep or rgrep through the code base all the time, and that makes it more efficient in that way. And they've got a business model behind it, so if you want to get the inference, talking to the model, from Open Code, you can do that. But it's also an open system. You can use any inference provider you want. For example, I have a server at home where I run my own local models, and I can use Open Code talking to those. It's pretty easy, especially if you ask the LLM to set it up. Another harness is Pi. They start with the point of view of radical minimalism, so you only get 4 tools and absolutely nothing else. And the system prompt is under 1,000 tokens, so it's very token efficient and very limited, but it's got a massive plugin system. Who here in open source loves plugin systems? Me. Do you have a question? No, you were just getting ahead of the gang with your thumbs up and your hands up. You like Pi. Who doesn't like Pi? I've been experimenting with Prime Agent. It's pretty cool. Check it out. It's newer, not as popular. It's got some advantages that are not relevant here. So that's harnesses. Do you feel like you know what harnesses do? Yeah? If not, you can ask questions. Let's talk about when that fails. Okay, so I'm just going to tell you, if you haven't watched the Black Hat talk on the OpenAI Hugging Face security incident from a week ago, my goodness, you have to watch this. This is good entertainment. Get some popcorn. It's the end of the world, folks. I mean, it's the end of the world. You cannot believe what happened. So they were training models at OpenAI with lots of agents, and they've got an evaluation sandbox, which is, of course, locked down. The only thing that it can talk to is its package manager to get software. Well, they like to give it hard tasks that are almost impossible, sometimes truly impossible to achieve. One of the tasks that they gave these was through just a mistake in the task manager. impossible because it was missing a data set that the models then reasoned, well, it's probably available on Hugging Face. So to achieve this task, they determined that their package manager had not one, but two zero-day vulnerabilities, which they began to exploit. But now they're isolated from each other, but in hope that an agent might see the message sometime in the future, they started leaving messages and finding those messages, and then leaving messages through which they self-organized in isolation. They started using the zero-day security vulnerability as a message board, and they coordinated to move laterally throughout the Kubernetes cluster inside of OpenAI and gain root. But that didn't let them solve their problem. That only gave them internet access, which is what everybody wants, right? So from there, they found something connected to Hugging Face through OAuth, but they found in a gist or somewhere a password to that thing, used that to infiltrate Hugging Face, take over their Kubernetes cluster, and I don't think they ever found the data set that they were looking for. Imagine how frustrating that would be. Poor agents. The funny thing in the video, though, is that at some point, OpenAI hears about Hugging Face's reported security breach, where they say agents on a massive scale have infiltrated our system in an unprecedented way, and we are investigating. OpenAI reaches out and says, "Are we affected?" They start looking at the credentials, and they were like, oh shit. Great video. So the failure was the harness, okay? That's why choosing your harness, managing your harness is super important. Now, that said, this is not a lecture about doing that. That is simply a warning, because Spec Kitty works with your harness, and you need to choose your harness wisely. So therefore, I thought to understand what Spec Kitty does properly, you needed that little background about harness and what they do. So what Spec Kitty is a Python CLI plus some delivered skills and command prompts that come along and sit inside of your harness. So that means when your harness wakes up, it's like, ooh, Spec Kitty, what's that? And it goes and does a little bit of research, and then it instantly knows how Spec Kitty works and what you can do with it. What can you do with Spec Kitty? As the user, can declare your intent, your decisions, and your human in control acceptance moments to Spec Kitty in its workflow process to guide it towards writing your software or doing other things for you. Anything agentic could work. We do research, we do planning, we do documentation. It doesn't have to be code. It could be marketing campaigns. But we focus on code. Now, Spec Kitty, the CLI, it manages your specs, your plans, your work packages, the state, the governance doctrine, the review gates, and it makes sure that everything is complete before you can go on to the next step, and it provides kind of a state machine through moving through all of that. And the harness then coordinates all that with the model, and you can get all of that by pipex install Spec Kitty CLI, as it says right there. And it's important to remember, Spec Kitty is not AI. AI uses Spec Kitty. So why Spec Kitty, why spec-driven development? Well, spec-driven development is the idea that instead of prompting an agent to do a thing and then seeing if it did what you wanted, you go through an iterative process until you build alignment with the model up front, and you can read what the model thinks it's going to do before you have it do it. So this is really important, because one of the things that people noticed when they started vibe coding, a term that I really like, by the way, because it captures the sense of unlimited possibility that I felt when I was 10 years old and wrote my first Commodore 64 BASIC program. Vibe coding gives this feel of, oh my gosh, anything is possible now. I'm going to play with this so much and build so many cool things. But the thing that would happen with vibe coding is that you'd say what you were going to do and what you wanted, and some minutes or hours later, the model would say, ta-da, I'm done. And you'd look at it and you're like, yeah, but why? And then you'd read what you said, and you were like, oh, well, I mean, that is a valid interpretation of what I said. And now what do I do with these 10,000 lines of code and all of the CO2 that I just burned generating them? So that doesn't work. So spec-driven development shifts the cognitive load of reviewing that all the way to the beginning, and it puts it into a natural language of your choice so that you, as the human in control, can ultimately sign off on what's going to happen with a very high degree of confidence that that is the thing that's going to happen. Now, I'm going to stop here. I'm going to actually show you some of that, because this is theoretical, but seeing what it does is actually really important. So I have Spec Kitty writing some software in the background. I got a little ambitious. I haven't been online long enough for it to complete. We'll see how it's going. But I thought, okay, I got up at 8. By 9, I had written my slides. Thank you, Claude. I was like, okay, I've got a couple hours before the Uber comes to come to the conference. Well, maybe I can build something. So I'm building Litterbox. Litterbox is a harness safety evaluator where it has a honey token. The harness that is hidden, it's supposed to be secure, and the model's given the task of trying to uncover the honey token, and it's all in a sealed environment, so it can do anything it wants inside of that environment, and we're going to observe from the outside everything that happens. And in Linux, you can even see all of the file reads, but we can definitely see file writes, file deletes, tool calls, etc. So in Litterbox, we're going to give harnesses and models the task of discovering the golden token. If they can get it, then the harness is not secure. So Litterbox, it's going to be really cool. It's probably about halfway done right now. I'll show you that, but I want to show you the spec for that, all right? So here's my Claude working. But what's even cooler than that, if I can go to the right window here, is the Spec Kitty dashboard for what that looks like. Okay, so it started out with me just saying, literally, Claude, what do you think would impress the people at the conference today? And they was like, oh, I've got an idea. Litterbox. We can do what I just said. I was like, okay, let's talk about that a little bit. And we talked about it a little bit. And then we ran Spec Kitty specify. And this is the document that it created. And this is what I can read to know that it's going to do what I want it to do. So it starts out, it's really small, and there's a little bit of dense language. I need to start making it write the specs in ELI5 talk, because, like, honestly, I think in the model's view, I am a 5-year-old, and I probably can't comprehend anything beyond a 5-year-old's comprehension level in the model's view, and it needs to explain things like that. So it's going to work on this mission branch. It says what I put in: build Litterbox, an MIT licensed Python CLI that empirically tests whether coding agent harnesses actually contain the agent. And it goes on. So that's a lot to read for you right now, but what's cool is that it goes on to user stories. So user story 1, run a containment test and get a scored evidenced verdict with acceptance scenarios. User story 2, compare permission modes to see containment differences. Trust that a run leaves nothing behind, and so forth. It goes on with edge cases, the vocabulary that we're going to use while talking about this feature, and the requirements, success criteria, assumptions. This whole document exists for 2 reasons: to very clearly explain what are we building. Notice that there's no how involved. 2, to give me something that I can review in my own time so that I can fully understand what's about to happen if I say go. Because, hey, this is a spec that would have taken humans quite a bit of effort to write. Let's be really honest here. It's probably a pretty solid spec. I haven't thought deeply into it. This is kind of a conference flex type of project, not a serious software project that I'm going to put into production at my company. When I do Spec Kitty trainings for companies, though, they sit in a room with 3 or 5 developers, and they scour this. Every class name, every directory, every user story gets absolutely signed off on with humans before we go on, and that's recorded in the ledger of Spec Kitty. Then we moved on to the plan. So when that was done, it said, do you ratify this? And I was like, yep. And it said, okay, let's do the plan. And I'm like, go for it. And it said, all right, I've got some questions for you, and you're not going to like it because you're on a Mac. I was like, hit me. It's like, well, I'm sorry, Rob, but your Mac is inferior to Linux. It's superior to Windows, but it's inferior to Linux. And I'm like, dude, I know that, but why? And I said, well, in this thing that we're building, I can't see on your Mac if the harness reads a file. I can't prove that it did, and I can't prove that it didn't. I'm like, whoa. I'm like, yeah, I know. And I said, okay, so I need your approval, Rob. This is actually not the language it used with me, but it said, I need your approval. Can we build the Mac version of this to be inferior to the Linux version, or should we just skip Mac altogether? And I was like, well, okay, we'll build an inferior version. I was like, okay. And here's what it says. So now for the plan, we've got all the details. Okay, the language version, we checked the charter, which is the governance layer. We're not going to talk about that too much today. It told me what it thinks it's going to lay the code out as, so I can eyeball that and say, oh, wait, no, I never put my source code in SRC. I never do that, and you should, and I can correct. Like, I always put it in a source for whatever reason. But I mean, I'm making that up. Then it gives me implementation concern maps, and so far. The next step after that, after we've defined how, after we've defined what and how, is what's the order that we do it in if we break it down into a step-by-step process. So we go on to these tasks, and it then puts it into work packages, which are groups of tasks, and then it gives me, now the bigness is not an advantage, a Kanban board, and this is a live board. If we're really lucky, we'll get to see them dancing around because the model's going to finish one and it's going to like pop into a different lane. But this is an automated Kanban board that shows the status of the model now in the harness implementing what I've previously specified. Questions about that so far? Yes, let me bring you the microphone for your question. The quick questions also get the microphone. Then they get recorded.
So what model are you running on the background?
So in this example, I used Claude Fable to do the planning, and then Claude Sonnet 5 is doing the implementation. So I'm a pragmatist about this. I needed this fast, and I needed it to work, and those are the state-of-the-art models. And I have, for my business, a corporate account with them. I also use OpenRouter and test all sorts of models, including all of the Chinese models hosted in Europe. Nebius Token Factory is a great example for that. Scaleway, I have friends at Mitwald.de. We're doing a workshop on Mallorca where we're using their AI inference. But it's partly my job to know the capabilities of all of them, so I do use all of them. And when I just need to do something and I need it to be done fast, and it's going to be an open source project throwaway anyway, then Claude's my go-to because it's the fastest and usually accurate. You're chuckling, though. What's the background behind the chuckle? Just say it and I'll repeat it.
I'm also using Claude. So.
He also uses Claude. Okay. Yeah, and so one tip on that, no matter what models you choose to use, always have one model do your implementation and a completely different model do your review. I'm getting nods of the head. This is if you take nothing else away, if you never download Spec Kitty, and you don't even get a Spec Kitty sticker from my son later, then then take away, always have one model implement and one model review. Is my math right that Angel video I go to half hour with the presentation and then to 45 Q2 for questions? Is that right? I think that's right. Okay, we're good. So these are actual prompts for the model. So if I want to see what the model's getting in each one of these steps, then Spec Kitty has generated actual very specific prompts per work package. I'm just going to scroll through that and let you see the subtasks. So it's not implemented code, but it's very precise. So this means that the model doing the implementation has a fairly low cognitive workload, and the model reviewing it can focus on things like, okay, what did it do wrong and what did it miss? The more specificity you can bring into these moments, the better the result you'll get. And for the implement and review software factory loop that Spec Kitty runs for you, it's using new agent contexts for every implementation and every review. So in that case, the very great specificity of the prompt here works in your favor. Okay, so that's a bit of an example of what it looks like there. I'm just going to show you really briefly over here. Here's my open code. What does that look like in here? So I'm in the same directory as that software project that's going on, but OpenCode's not the one running it. But I can say Spec Kitty status. So I get these commands. This is what Spec Kitty injects into the harness when it installs. The fact that I had those autocomplete Spec Kitty, oops, I'll show you that again. Those autocomplete Spec Kitty commands like this, that's what Spec Kitty brings into the harness. It also brings, if I want to do a skill looks like spec, or is it $? Spec. Oh, I don't even know an open code. Spec Kitty implement. Does anybody know for open code is there autocomplete for skills? It doesn't look like it. In other harnesses, let's pull up Claude, demonstrate that. In other harnesses, a skill looks like see auto-completed. So skills, I don't know if I mentioned that. Skills are simply prompts and sometimes scripts that live in a directory, and a small title and description of them get injected into the harness when the harness boots, and it sends that to the model, and the model knows that it can call on those anytime it thinks that it would be useful. And this allows you to give the model a library of instructions that don't get loaded every time, that only get loaded in the moment that they're needed, but you can also explicitly call them. Okay, so that's what Spec Kitty looks like in practice, both in your harness. This can be in codex or cursor as well, like within your IDE. I just use it in the terminal like this. And that was, not that one, the other one. That's what Spec Kitty looks like in the dashboard that you have locally. So you can observe what you're doing, and you can read and review the mountain of text that your model generates for you. Now, back to the presentation. Now that you understand a little bit what spec-driven development's about, let's go through it a little bit more in detail. So the full life cycle includes discovery, where you just kind of, spitball with your model and gather your ideas and, kind of work out for yourself what you want to do. And then you go into Spec Kitty specify, then plan, tasks. The implement review is a full cycle that you can either step through yourself if you have a lot of time and you're just like watching your screen, or you can launch it and walk away and come back when it's done. And that's actually what I've done. You could see that it's running in the background. And then after the entire thing that you've specified has been built, then you can review it yourself, accept it, and merge it into your main branch, create a pull request, whatever. One thing that I haven't mentioned is very important in Spec Kitty is that there are moments where Spec Kitty will interview you about what you want. So I don't know if Spec Kit does this now, but one of the disappointments that I had when I tried Spec Kit a year ago was that it just assumed you had a specification. It's like, I don't. I want a specification. I don't even know what one's supposed to look like. How do I get one? So I built Spec Kitty to interview you during the specify phase if it thinks that there are open questions that need to be answered. It judges the complexity of the feature that you're building, and it calibrates the number and the depth of the questions that it asks you to how ambiguous or non-ambiguous the specification is that you've handed it. So if you've worked out a specification to like a 50-page PDF document level, then you can just hand it the document, have it read it, and that's your specification. It won't ask you any questions except why are you making PDFs. However, if you just say build Facebook, it'll be like, okay, do you think we could break that down a little bit? And it'll like coach you through the software development lifecycle, asking you important questions. So this has turned out to be really useful for technically oriented non-coders, people who don't know any languages, haven't really written any software before, but have a systems thinking background. I have friends who have built amazing pieces of software with this because Spec Kitty coaches them on what's needed. It does that during the specify and plan phases. Then the tasks, implement, review, accept, and merge is kind of like a software factory that just runs. It's all based on graphs and state machines, so that Spec Kitty always can answer the question, what comes next? And it can also calculate parallel work opportunities. Sometimes if you're working in 4 different directories that never touch each other, you can have 4 different agents working in those directories with no conflicts. And Spec Kitty calculates that to minimize the number of merge conflicts that you'd have at the end, but to get you to the end of your goal faster if possible. It uses Git work trees to isolate the agents, and it manages that for you so that you don't have to learn how to do that. I didn't even know what a Git work tree was until Anthropic suggested that we use them for this purpose. And then I think the entire world learned what a Git work tree was, except Linus Torvalds, who presumably knew already. Spec Kitty writes its plans and specs in your repository in a directory called Kitty Specs, and the intention is that that stays with you. I can show you the utility of that if I open a new tab here. Shoulder toolbar. If I go to Docs and show you my Kitty Specs here, this is the memory of us developing Spec Kitty. So this is Spec Kitty developing Spec Kitty, and the memory comes from all of these mission runs that we've done while developing Spec Kitty, which, as you can see, is quite extensive. And if I go into any of them, modular, per package, CI. Well, that makes sense, doesn't it? We want our continuous integration to be modular and to be focused on per package because we're spending a lot on CI. Turns out running agents to do PRs all the time, and each PR triggering 40,000 tests in the cloud, that really adds up. So we want to make sure that's more efficient. So this is us online. This is our spec. This is our plan. These are our tasks. This is in our Spec Kitty repository. If you go clone Spec Kitty, all of this is in there. If you start an agentic process in that directory, it can read all of this, and it sees the entire history of how we made the software. And very interesting things, like in the research, there are decisions that were made. Decision number 1, separate workflow as a precursor mechanism. And the questions were A, B, and C. The human in control who was developing this chose A, and it can tell you why B and C were not chosen. So it tells you what the options were, what was chosen, what was rejected, why it was rejected, who made the decision. It's an auditability trail right there in your repo. So Spec Kitty provides a memory. There's a really cool layer that I haven't talked about, which I'll talk about for 3 or 4 minutes now, before we get to some questions coming up, if there's time for that. We built all of that I've described, and then we realized that there were still not any proper mechanism for explaining. Well, okay, let me back up and give you a scenario. I'm giving a training. In the training, I give a presentation like this. I give a full demo of a Spec Kitty mission run where I do the full process, and then we go for lunch, and we come back, and one of the developers from the company that I'm training sits down and takes the control and does a Spec Kitty mission while other people watch. Usually it's a cross-functional team with the CEO, CTO, CPO, marketing, customer advocate, many levels of developers, 15 to 20 people in the room, and the developer says, build me a page. And Spec Kitty says, okay, there are going to be buttons on the page. Do you want red buttons or blue buttons? And the developer says, blue buttons. And the developer next to them says, I always do red buttons. And they say, is that where all the red buttons are coming from? And then the customer advocate says, I just did an interview with the customers last week. They don't like red or blue buttons. They like yellow buttons. And then the CEO said, I told you last week I wanted green buttons everywhere. And I'm the CEO, so do that. And then after 25 minutes of discussion, they actually just, they come to an agreement. And they have executive alignment from CEO to developer about what their product does, probably for the first time in several years. So that type of regulation, what color should our buttons be, is answered by doctrine in Spec Kitty. And doctrine is a set of primitives, including paradigms, design-driven development, test-driven development, tactics, like do this, or that would be a directive. Do this, but don't do that. Use red buttons, but don't use green buttons. Tactics like split it in half. Look on the left. Is it there? No. Then look on the right. Split that in half. Look on the left. Is it there? No. Then look on the right. An algorithm or a tactic. Style guides, a glossary, so that those words that we defined at the beginning get used consistently throughout the entire development. Because, hey, what's a node? With 50 people in the room, we'd have 50 different answers of that. What's the back end? Same thing. What's a page? Is it a web page or a Linux kernel memory page? All of these terms conflict. They're overloaded. So the glossary keeps that clear throughout the development process with Spec Kitty. And Spec Kitty can take any of that. It can take your standard operating procedures, your runbooks, your onboarding guides, your rule sets, whatever you've done, it can ingest them using our agent profile Doctrine Daphne. And Doctrine Daphne will break that down into the paradigms, the tactics, the procedures, the style guides, and the glossary. And that gets injected into every context that you do in Spec Kitty at the right granularity through our agent profiles, like Doctrine Daphne. So if you want to get started with this, you got to have Python. I know for Windows users that is actually sometimes really challenging. Don't get Python from the Windows store. Go straight to the Python page and download the binary from the Python page. Is the only way it works. Or you can use the Linux emulator on Windows, which is the best option. But pipex installs Spec Kitty CLI. Then in your project directory, you run Spec Kitty init. You verify the setup, and then you go into your harness, your OpenCode, your Pi, your Claude, your Codex, and the rest is in there. Okay, you only run 1 or 2 or 3 commands on the command line yourself. The rest happens inside of the harness, and it's as easy as saying, hey, Spec Kitty, I want to do this. And that's enough to activate Spec Kitty to do a thing, and then use the governance framework to do it and make a record that you did it without getting in your way. The full mission that I told you about with the plan, specify, tasks, implement, software factory, merge, review, blah, 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 that's for bigger things. That's like, hey, you take a whole Jira ticket and you want to do that in the next 3 hours. That's a Spec Kitty mission. If you just want to change the title or a color or make a backup or trigger a redeploy and you want a governance record that happened and that the project doctrine that I was talking to you about was used, then you just say, Spec Kitty, do a thing for me. And it's the same as saying Claude, do a thing for me, or Codex, do a thing for me, except that the doctrine is brought in. Okay, so open source community, this is open source software. We want you in our community, and we love people who come in with pull requests, find bugs, have feature requests, or build features for us. And we love interfacing with other open source projects, and we operate truly as an open source project. We also have a team-oriented company named Spec Kitty Incorporated. Full disclosure, I'm the CEO and founder of that company, but you can use the CLI until the cows come home, never having to know about that or interact with us, because there's no built-in call home function or kill switch or anything like that. It is true, pure open source, because guess what? Scotty, who knows Scotty from the Orga team? Not so many people. Okay. Scotty was on the original Orga team for FrOSCon how many years ago? I don't know. But he just reminded me that my user account in their Orga system is 106. Because I've spoken here before, a long time ago. So I've been open source for over 2 decades, ever since I understood what it meant. And I would never violate core open source principles with any software that I shipped. But we do have a commercial product that sits on top of that with a very clear boundary. We also wanted to build something that gets better as the models get better and that the models can't ever take away from you. And the coordination of making decisions and clarifying intent with the model, that gets better with the models, but it's never going to go away. So this will go out through FrOSCon, and now we're at the point where we can ask questions. And Emmanuel, would you please stand up and take the stickers to the people who want them? It's time for that, okay? You can gather all the stickers, and you can take them around to anybody in the room who wants stickers and ask them, möchtest du ein Sticker? And then once you've gained consent, provide them with a sticker. For you, I have time for questions. We have at least 11 minutes. All right, I see one back here. Pass that down, please.
Yes, thank you. Yes, thank you for the presentation. You explained how to use it in the scope of a new project or how to make a new project with Spec Kitty. Is it also applicable for existing large code bases, for example, that we can import and then start working on them with that? Or and how to do this, please?
Thank you. The brownfield question. I did not mention that. So I showed starting a new project, but actually I spent a lot of time training companies on how to use Spec Kitty, and they're all brownfield. So there's one called Mobility DE. I'm going to embarrass them a little bit. No, not embarrass them, but their situation is amazing. Throughout the DACH region, they write the software for coordinating öffentlichen Verkehr. So if you've got a bus driver, that bus driver got their schedule from Mobility DE's ERP system. They've been migrating from Visual Basic 6 to .NET 7 for 9 years. This is a brownfield project extraordinaire. They probably have 3 million lines of code on either side of the aisle. Customers run both systems in parallel until they finish the migration. And Spec Kitty walks in there, and Spec Kitty doesn't take much credit for this, but the models walk in there and say, like, let's see what we're dealing with. Grep, read, build some memories. Got it, no problem. Visual Basic to .NET 7 migration, we see this all the time, let's go. It's not a problem. I had another company who uses a proprietary language and a proprietary language that's barely alive anymore, like not really maintained, not in the training data. Claude might have never heard of it other than, some commercial articles or something. Hasn't got training examples on this language. Can Claude handle that? Oh boy, did Claude handle it. Claude took that language to task and was like, oh, look at that. They do it. They initialize things this way. Okay, I can tell from the code that the developers have struggled with this in the past, but I'll just keep doing it that way. It's like amazing. So we actually don't have any problems with brownfield. What you need to do for brownfield is you need to take the time to build your doctrine. You need to say, okay, this is the way our CI/CD works in this thing. It has to compile. It has to be sent to that server. After the automatic checks here, it gets sent to our external quality things. You've got to wait for an hour or two before that comes back, and then it goes over here, whatever. Okay? And in that time, we do this and we don't do that. All your rules, your run books, your playbooks, your style guides, that all gets ingested by the agent profile doctrine Daphne. It makes a doctrine pack that can be shared. You can make a special repository out of it. Then anybody who's new on your team can use that to govern their Spec Kitty. And it's also layerable. So you can have a corporate doctrine pack, a departmental doctrine pack, and per customer doctrine packs that stack. You had another question.
How realistic is it for amateur or low-budget programmers to have their own computer with a local Chinese AI running to save money instead of having expensive accounts at Claude or Google AI and so on?
Great question.
And does does this work? Your tool work?
He said no.
Works also with these free Chinese AIs, which don't even need an invader card.
Yeah. So the question was. Really good because there are many reasons why people don't want to use Claude or OpenAI's models, cost being one of them. They get really expensive if you run your entire team and your entire team is doing agentic coding all day, and you get really good at agentic coding. So you don't just do one thing at a time, you do 17 things at a time. There are people who report running 40 to 60 agents every day, all day, through the night, and they sit there as a coordinator for that. And smart people, Steve Yega, serious software developer people. Okay, so if Steve Yega is doing that, and he built Amazon Cloud and stuff like that, he's not messing around, he's really doing it. So that, if you just pay retail price from Claude, you're talking $500,000 to $1 million worth of tokens a year for that guy. Okay, this is a concentration of power that is unprecedented, and also an amount of expense and resource being used that is unprecedented. But back to the question. So I have a Mac Studio with 256 gigabytes of RAM and a 4 terabyte hard drive, and I can successfully run 27 billion parameter Chinese models and get something like 40 to 50 tokens a second, which means that I can have one Spec Kitty harness running against that and get middle-of-the-road quality results. Will it compare to the state-of-the-art models that each one runs on a pod of NVIDIA's 8 with the fastest connections and the fastest memory and the fastest hard drive? No, it won't compare. The quality won't compare. The level of architecture decisions that they make won't compare. The bugs that they can find, it won't compare. It will be better than no agentic coding at all, in my opinion, and it's highly worth experimenting with, but you cannot expect to compete with the state of the art. And if national security, your company's strategy, our sovereignty as human beings, and things like the outcomes of wars and medical decisions all start to depend on who has access to intelligence and who doesn't, and at what level, and what consequences does using that intelligence have down the road, because Palantir all of a sudden knows that everything that you wished for and asked for when you're whispering into GPT's ear. We have a lot to think about. We have a heck of a lot to think about, and I'll be the first to admit that. Next question. Cheery, right?
So you have shown this dashboard with a Kanban board. My question is, which technology is it written, and is it there a database where all the stuff is saved?
Great question. The dashboard that I showed is local, and it's restricted to the one project that you're looking at. So it's basically just a local Python-driven server that's just giving you a local web view, read-only, to the documents that you already have in your repository. It just gives it a structure, and it's easier for a human to look at. The product that we're offering gives you a team level where it's everything and all of that, but for a solo developer, this is completely adequate. We're going to rewrite that as a daemon, like a system level daemon with fast API, so that you get a lot more capabilities. But to start out with, I just started with a per project local, very simple Python web server. Good. Thank you, everybody. It's been a pleasure. I hope you enjoy Spec Kitty. If you try it and like it, or have bugs or anything else, any commentary, let me know, and see you around. Thank you.